Okay, we are still in MDE 54, day 20. We're in the finance unit, and this correlates with your homework 3 of your Math 154 as well, and it's payout annuity. So usually when you get some large sum of money, it could be from retirement that you've saved up for or whatnot, or it could be something really fun, like you won the lottery. You might put it in and take money each account to live on. So again, a really common one would be a retirement account, where you now realize you have a certain amount and you want to figure out, well, what could I take out every month, or how is this going to work? So PO is the balance at the beginning. It's the starting amount that you're going to deplete. So maybe you saved 800,000 for retirement. That's your PO that you're going to deplete down. D is the regular withdrawals. R is the annual interest rate in decimal form. K is compounding periods in a year. And N is number of years you plan to take. So just as a quick reminder, monthly K is 12. If you wanted to take your money out quarterly, K is 4. If you were to take it out yearly or annually, a lump sum once a year, it could be 1. So there are several versions that K could be. So the formula looks like one we were just working on, where you've got some negative exponents and a couple other things going on. So as long as you follow the parentheses and identify your variables correctly, this should go pretty smoothly. And how you know something is a payout annuity is you're taking a regular withdrawal. A regular withdrawal. You're being paid out regularly. So you want to be able to withdraw 25,000 each year. So that's going to be your D. K in this case is 1 because you're only taking it out yearly. Account continues to earn 8%. How much do you need? Oh, and N is 15. So I like to read the problem, figure out what it is, and then go through and get all my variables. And then I'm going to put them all in. So PO, I do not have. I have D. 1 minus 1 plus R. K, when K is 1, you could actually ignore it if you want. I'm going to do the negative in K off to the side. It is negative 15, just because it's one less set of parentheses that I have to deal with, and then 0.08 divided by 1. So I plugged all that in, and if you type that in exactly where you see the parentheses, close, 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 open, close, you will come up with the amount that you needed to make this happen. So take a moment, get that in your calculator, get that in your Desmos, whatever you're using, type it all through and make sure your answer matches. So I end up getting 213,986.97. And if you put that in, you can withdraw that 25,000 every year for 15 years. Okay. 2 more examples with the payout annuity. Whoops, sorry. So I'm going to write the equation up here just so we have it. And again, it's just a lot easier to know what I'm doing if I have my equation in front of me. Okay. So we've saved this nice lump sum for retirement, 450,000. So that's great, right? That's my PO. Your account earns 0.0575. If you're ever not sure, take that number and divide it by 100 to get the decimal, don't round. How much can you take out monthly? So K is 12. If you want that money to last for 25 years. Okay, so here's one like in the previous video where you actually have to solve for D. So to solve for D, we're going to go through and actually solve this piece and then divide PO by it. So then we're going to take it into that PO. So it's 450,000. D is now out. I'm going to remove one set of parentheses. from the outside and put the rest in. And then negative NK. And remember, I cut this set and I cut this set. Okay, so I have all that. I'm actually going to come over and do it on Desmos so that it looks a little nicer for us. Okay, so what I had written on the previous page was the 450,000 equals D, and then I put all this off to the side. And again, this is just free software. And we are going to do this whole chunk first. This guy. And get that answer. Okay, so let's get that in. 1 minus 1 plus 0.0575. Oh, I typed something wrong. 1 plus 0.05. I also like this because I can look. Arrow to the right to get out. Now, when I do this piece, it'll give me, I've got to put this negative 12 times 25 in parentheses and then arrow out. And I have to put it there because it doesn't know that you want to do that. Okay. And I come up with this number. Okay, so I've got my 450,000 equals D times this guy. So I'm also going to divide. And that'll end up giving me what my D is. So I'm going to come over here and take 450,000, and then the entire number, you don't actually want to round it because it'll be enough to make it wrong. Okay, so then I end up getting my answer. And that's through Desmos. So my answer ends up being 2830.98. So this particular retirement account, he can take that out monthly. Excuse me. Okay. So then we're going to work this another way. The next person, Brian, wants to withdraw 50,000 a year for 15 years, and an account earns 10% interest. So what does he need to start with? This one is asking, what's the PO going to be? How much do I need to have in there to get that money out? So my D is 50,000. My K is 1. My N is 15. And my R is 0.10. So I'll set it up as PO equals 50,000. 1 minus 1 plus. You don't have to divide by 1 if you don't want to, but I did do NK separately, just so it's not as messy. All right. And you should be able to put that in exactly how I just wrote it and come up with an answer. Okay, so that gives you 380, 303, and 95 cents. So if he wants to withdraw that, he needs to save up, about $380,000. So then the question is, how much money will he pull out of the account? Sorry, this is an 8. How much money will he pull out of the account? Well, if he takes out $50,000 a year, one time a year for 15 years, he's actually going to take out 750,000, but he only put in 380. So that's the cool thing about the savings annuities and the payout annuities is they keep earning interest even as you're taking money out. So the interest is going to be the difference in the two amounts, which will give me quite a hearty amount. You almost doubled it by leaving it in there to grow as you took it out. Pretty cool. All right, that ends this video for payouts.